Okay, so let's just quickly comment on the programming part. So just the back substitution. If I can find my solve matrix system, or I need to open here. So let's look at just quickly at the suggestions. So essentially for back substitution, I know that my back substitution starts with the last element, if I have upper triangular matrix, and it starts with the last element. The last equation is really simple. X of n is my b element of b of n divided by a of n. Okay? And then after that, I have to basically plug in that xn into all of the equations above. So I start first with the equation n minus 1, right? And I plug in that xn, and I can solve for n minus 1. If I have only 3 elements, then basically you can see algebraically that your x of 2 will be a b of 2 minus your element a23 times x of 3 that you just computed, and altogether divided by a of 2. Then if you plug both x of 3 and x of 2 into the one above, which is solving for x of 1, then you can algebraically see, if you look at the 3 by 3 system, that this is basically the solution for your x of 1. So now you can actually see, let me put it in full view. The whole key in solving for back substitution is to basically assign this last element and then have a for loop that goes from n minus 1 down to 1. And then there's this sum here, this one, that kind of keeps growing as you're going down to 1, and you have to figure out another for loop that will create the sum for every step of the way. So basically you need to find sort of how does this look like for general ith equation as you're solving for x of I. Okay? And that is the key here, is sort of like making this more general and work for n by n system. So I'm gonna,
In order to make this step easier, instead of making it from a lower triangular matrix, if we just had it completely pivot and get zeros everywhere, would that still work? And then we would simplify this step.
Yes, but then it's not, yeah.
Is it just
You could do that. There is less, I believe the reason why it's set up this way is that there is less number of additions and multiplications that you need to do if you do it this way. Yeah. I'm actually going to verify that. And again, that's important. Why? Because in a 3 by 3 system, not an issue. Okay? In 1,000 by 1,000, you're doing so many multiplications and additions and so many round of errors that they do pile up, and that's affecting the solution of your system. Okay. So the way the algorithm is set up is to try to minimize that if you only can. Okay. Any other questions? Yes?
Say you want to go from like for I equals 1 to 10, can you do for I equals 10 to 1? Or you're not going to let you go back?
This backward substitution?
No, like just for any for loop. Can you go backwards like 10 to 1?
Oh, okay. The way we program forward elimination, I think if you start from last one, yeah, nothing really changes.
Okay, it'll work. Because I was having trouble. I don't know.
Well, the only thing is like you should left your pivoting position untouched.
Yeah, I'm not talking about this question. I'm talking about in general for a for loop.
Well, it depends on the problem. So for loop depends what that for loop is doing. So it's here in back substitution, for instance, I have to go from n down to 1. Because I have to first solve for xn in order to find xn minus 1. So if I start going from I to n, it's not going to work. Okay? But if I had actually so-called forward substitution, for that I would have to have a lower triangular system, not upper triangular system. Does that make sense?
Yeah.
Okay.
I thought he was saying like if you can make a for loop go down, in which you just use a -1 increment.
You can.
Yeah, I think that's what it's.
Use -1, yeah.
Yes, sorry. So your question was simpler than mine.
Yeah.
I like that. Alright, so yes, you can step by anything.
Do I have to put the step in, -1?
Mhm.
You would have to
Yeah.
put -1.
The other default is 1. So if you
Right.
don't put anything, for loop is thinking that you go by 1. So if you say for loop from 5 down to 1, it's not going to execute because there's no way to do that. So you have to go by -1. To that end, it could go by -0.5,
Right.
-0.36, whatever you can come up with, you can actually do steps, but you have to specify what the step is. So in your backward substitution, the for loop will have to be from n-1, colon -1, down to 1 in order to work. Okay? So let me give you, let's work on this for about 5 to 10 minutes and we'll help. If you haven't done backward substitution, work on it. If you have done backward substitution, then I would like you to work on a timing problem. Okay? So time, how long it takes to solve systems for size 1,000, 2,000, up to 5,000. So we're going up by 1,000. Both using MATLAB and your Gaussian elimination procedure. And this is just a timing exercise. I don't particularly care which problem am I solving as long as it's size 1,000 by 1,000. Okay? So use basically a random operator that ran to create yourself a matrix A of desired size and matrix B of desired size. Okay? So if you're done with Gaussian elimination, then work on this. If you haven't done Gaussian elimination, then please complete forward and backward substitution and ask us questions. And we'll give ourselves 10 minutes or so. And then also to check for timing, do help on CPU time, tick or tock. Those are CPU time should be enough. So basically measure time just before, measure times after, and see the difference to see. And if and when you're done with all, then try to push it a little and see what is the largest system you can solve. That can leave your MATLAB hanging. You might need to kill it. I did that a couple of times this morning. You didn't like it? So again, we're here for questions.
So when we're doing CPU time, we just put that in.
So measure time just before solving. So let's say that you're saying x is equal to a slash b. So measure time, say t0 equals to CPU time. And then after solving, say t1 is equal to CPU time. And then the difference between the two will be precisely the timing that it took whatever you had in between, right? So you can time whatever.
Is there like a timer? Is there like a timer function in MATLAB?
No, you use CPU time and you measure time just before, measure time just after, and do the difference and you'll get time. And
CPU time?
CPU time is the. And tick and talk, I'm not forgetting, but I think tick and talk kind of give you a little prettier output. In hours is necessary. And also, if you have your Gaussian elimination versus this MATLAB operator, I'd like to see who's more efficient. My bet is on MATLAB. Because we don't know actually the algorithms it's using, but it's optimized.
I think it's taking spot, like, when you use them together, you don't have to subtract.
Right. So that's just a, whatever you'd like. Just give me the time.
Okay, so I can just put our CPU on this at the beginning. Okay.
At the beginning and then after. That's how you time it. Uh-huh.
See, that's when we're gonna do this thing is 0.
You just decide if there is a substitute if there is
Are these back? So I would say that,
Where is it?
so your J says I plus 1. I is it, you're gonna ask for any. So, first one you know, I would say excellent.
Yeah.
So, oh, granted, yeah, excellent is so. Yeah, I think some should be always
Oh, no, I did.
I'm always impressed with this. Really far.
restart. And then what about this? I would say so this will not, your problem is that it will not work for I as a percentage. But you can pre-compute.
Because now you're not working.
That one.
now.
Yeah, I'm not doing that.
Oh, minus divided by A. So the first one you have. And then you can
Then you need
this will work.
Tonight, no, sorry.
This first sum.
You go to Rosoy, you're like, this one's in you.
Yeah.
Really good.
I am on.
I had less.
Did you? What happened? Did you finish the That's
Or,
Yeah.
yeah.
Did you finish it? Is it like,
You have to input the function.
Yeah.
Yeah.
Like,
Yeah.
That's the only thing.
Yeah, you have to input an A and B
I don't
column.
think that should be. That's only part of the problem. So 350 is
So
correct.
the thing is that
Where's your matrix?
No.
After, so like, how would I make it?
wait, what is it?
Making this so easy. This
You
is
have to do more than how is
So A.
you need to check the fuel. If there is a fuel, first you need to solve that.
Do you have a figure?
Then you always proceed with combination. But if AI equal to 0,
Where you're using
if it is not, then
What is the CPU time minus TV? Let's see. Oh, there's this thing where I can spit out.
I suggest you to just try this.
So R says
Then come back and
Oh, that's what.
because this is the core of the class.
this. Right, but why is it in
This one can be added. First when you are first,
I got to listen to it.
then come back and do this.
So, if I gave the matrix that I could just not do it.
Yeah, that's really comes here too. Rather than given as zero, here, that was zero. Looking for a non-zero. Yeah, I'll change those.
My dad's actually like apparently I was with my dad on the bus and apparently like it's
Oh, so your B.
yeah, there's when you special properties, right? And
So when you're
I mean I did that was
Right, it still gave this, that's not the problem.
yes.
yeah.
No, you will kill this once
Already
you
eliminated some
solve that. Right now,
So if you add an
it's rolled over anyway.
It works, right? So the
Yeah, I was just doing some yeah, yeah. So the pivoting, changing those,
I'm gonna,
I got 7.6 seconds, is that a reason?
or anything else. Because, yeah, everything left is actually zero.
Seems like,
But anyway, yeah, so you can.
did it take 7 seconds?
now break.
Yeah, it's. No, it's
It's not
super hard.
This K means
Yeah,
yes.
it's not super hard.
So I is equal to
No, I think it's running. Actually, I've never tried.
because B of zero is zero. But that's actually. Well, that's actually correct.
Oh really?
So give it a different. Are you sure that that's the B? And actually, yeah, so actually we were dividing something that was different. Let's do this. So that's.
Yeah.
Yeah, yeah.
That's not
Oh, this,
That's what I got.
then there will be, so let's. So you do have a problem.
I mean. Yeah.
Yes, it's.
You know,
minus-
so much is
So you have an issue. Given it. So possibly given it in the larger system, and you did.
Yeah, but
Yeah, I mean, let's say that's not they're always like here's the thing, like, you know how in I guess the like do you think there's more of a better use for time?
Oh, so you're not making enough yeah. Between a reduced row and low. Oh. I don't know what it is. But I mean, just for this, what is it? Yeah, there are no yeah, so I mean,
No, like I because I know a lot of like
but you can understand.
I guess we're very that's how we were raised. I guess that's
That's the
really wait, is this
There was a typo there. It's easy to switch INJ, and I don't even know what you have. I started rewriting. So this second one is
so work there wasn't complicated. Okay.
yeah, so
that's why it's 50% of the time. Questions?
With the glass
What
there
is
is
the time?
yeah.
Five 500,000 crashes. 5,000.
So
You can also know actually possibly collect the
so what you're doing is
Oh.
We're waiting on. What did you try a slash B? Yeah, 5,000 is fine. 5,000 is
so when you
So for 1,000, did anybody try both your Gaussian elimination and MATLAB? What's the result?
Yeah, it was
That fast?
No, I'm saying the difference between lines and areas. Remember the speed?
Right. Okay, so it's a very small difference, yeah. But on larger, I do expect it to be better. Let me try my computer. And again, different computers will also have different results. Why am I recording all of this?